Welcome, guys. So, in continuation to our previous explanation based on set theory, I would like to form another question that is different entirely from this. So, suppose we have, so I'm trying to form, so I'll try to form another fresh question in this case. Suppose we have a universal set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say up to 20, but not really up to that. Let's just leave it this way. So there is a way I could tell you what this is. I may decide to code the members of set A for you, so that you be the one to interpret it out yourself. Not that I'll just put 2, 4, 6, 8. Now be very careful of this. Some question comes in this format whereby you end up seeing this case whereby this kind of question that exists as okay, x is a member of positive integers, okay, such that let's say we have 4 is less than or equal to x is less than 9. So you have to be very careful of this. So I've coded this member for you. The members for set A have been coded. So you be the one to decode it. You have to decode this thing yourself. We list out its member. So you have to be very careful of this inequality sign. And then I might decide to code this one for you also. Set B. Suppose set B is just x such that um let's say I have something like this whereby I can easily say that okay, I'll try to form a question. Let's say we have 2 and we have less than x and we have less than or equal to 8. That's for set B. And C, let's say C is x is a member of twice of positive integers. So you should know you have to be very careful of this. So all I just want to tell you is that there are some cases whereby you be the one to decode it yourself, not that they will give you all the members. So to help you guys out, let me just help you guys out on this. So all these things here, it is equivalent to, this is telling you that x is a member of positive integers. Positive integers are just, okay, first let me tell you what integer is. Integers are counting numbers or natural numbers. So when I say positive, that is positive counting numbers. You know, counting numbers are 1, 2, 3, 4, 5, 6, like that. But if I write z negative, that means you have negative integers. That's negative of counting numbers, which you know, and that will be -1, -2. So here in this case, I'm dealing with just positive integers, and sometimes you might not see this, you might just see only this one, so it does not really affect. So to just make the statement correct, that's why this is there. And now here in this case, we have 4 less than or equal to x. You know, this is what we are considering the universal set. So we have to look, for you to list out the members of set A, you must look up to the universal set. Now here you have x is less than 9. That means 9 is not included. But here s can be equal to 4. Okay, s can be equal to 4. So let me just quickly call your attention to this. This 4 you are seeing, which is less than or equal to x, which is less than 9. So let me give you a very brief explanation. If I decide to cover this one, what can you see? I can see x is less than 9. Very good. And I can list out all the members of x less than 9, and that will be numbers less than 9 are what? 8, 7, 6, then down up to what? The least term you have, which is 1. So you can't go below this, because all these sets are being derived from, you actually derive it from this universal set. So you have to be very careful of that. So when I cover this, I have this expression. Very good. So whatever I want to do next now is I want you to cover this one. Then what can you see? I can see 4 is less than or equal to x, right? So let's write it out. What I see now is 4 is less than or equal to x. I can see 4 is less than or equal to x. But here in this case, it does not really make any sense, because the letter is meant to be on the left, while the number is meant to be on the right. So that's not a big problem. Just try to, when you're looking at this, if you try to switch this, like turn it anti-clockwise, just like this, you know what is going to become. If I turn the whole of this expression like this, it's going to affect the sign. The sign changes to greater than, it was less than. So when I turn it like a mirror, I'll end up having x is greater than or equal to 4. So do you understand that now? So that means x is greater than or equal to 4. Now you can easily interpret this. Yes, x is greater than 4 or x is equals to 4. That means x is equals to 4 or x is greater than 4. That is 5. Then you have to stop at 8. Okay, the element here is x is greater than 4, which is 4, 5, then like that. So if you now want to list out all the elements for a, now trivially x is less than 9, so you know what to do. And x is greater than or equal to 4. That is 4, 5, 6, 7, 8. Will I put 9? No, because from the range of set of x, I have it to be less than 9, so I can't include 9. So this is the element for B, for A rather. So the set of B, the element for B rather, is what? 2 is less than x. So I can do the same thing with what I've done here. Cover this, I have x is less than or equal to 8. That means 8 is included, and also the members, the other numbers are less than 8. That is 8, 7, then 6, like that. And here in this case, I have to cover this one, and I have 2 is less than x. When I turn this thing like a mirror, like anti-clockwise, I have x is greater than or equal to, x is greater than 2. And the set of numbers that are greater than 2 are 3. You start from 3, then 4, then 5, 6, 7, and 8 is also included. Do you agree with that? So what's the next thing? Here in this case, I have twice of positive integers. So be very careful. X is a member of twice of positive integers. So twice of positive integers are what? I just explained that earlier. 1, counting numbers, 2, 3, 4, 5, 6, 7. So when you take the twice of this positive integers, what I need to have? I'll end up having 2 times 1, that's 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. So I can't go, I'm not allowed to go beyond the universal set. This is the boundary, so I stop at 10. Do you understand that? So from here, I can decide to form any question myself. So I'll try my possible best to explain this. So all I just wanted to know is that for this lesson, what I want you to take note is sometimes the members of the set will not be reviewed for you. You'll be the one to decode it yourself. So it will be coded for you, so you have to decode it yourself. Okay, so you have to learn how to do that. Seek for more questions so that you see how the question comes. Okay, so questions now says find A intersection B complement. That's the first one. The second question, find B minus C. Third one, find A minus C. Fourth one, let's say I ask you to find A intersection B union C. And I don't want to form more questions, so let's just work with these 4. Let's work with these 4. Now the solution to this, let me divide this. So the first thing we need to consider here now is we want to find A intersection B complement. First thing we need to do now is write out your element for set A. A is 4, 5, 6, 7, 8. You all agree with that? This element for set A. Now, what is my element for set B? But I'm considering the question, I'm looking for B complement. So straight up, B complement implies, you know what this is? So B complement implies the universal set. Since there exists universal set, so the complement exists also. I can find the elements, the complement of any set of in this question. So that is universal set minus what? Minus set B, and that will give us what? This implies remove B from the universal set. So whatever you have left in the universal set gives you the final answer for B complement. Now let's start. You move 3, 4, 5, 6, 7, 8. Whatever you have left here, 3, 4, 5, 6, 7, 8. What I have left is now 1, 2, 9, 10. 1, 2, 9, 10. Do you understand that? So now my final question is, what is A intersection B complement? So do I have any intersection between this result, this set A, and this new B complement I have? Is there any intersection? No. Then that is what? An empty set. This gives an empty set. No intersection. So that's the final answer to this. So I hope you've gotten the explanation clearly. So that's how it works. Second question, find B minus C. So this one is very, very simple. B minus C means remove C from B. Okay? Remove C from B. Whatever you have left in B gives you the final answer for B minus C. Do you understand that? Okay? So now here in this case, that means remove C from B. That is, remove 4. What else can we remove? 6. Remove 8. Remove 10. No 10 to remove. So whatever I have left in set B is my final answer. So what do you have left? That's 3 and 7. That's 3, 7. So do you understand that? So that's how it works. So this is the final answer to this. And then for the third question, find A minus C. A minus C implies that remove set C from A. So whatever you have left in A gives you the final answer. Remove set C, remove 2, no 2 to remove. Remove 4, yes, remove 4. Remove 6, yes, remove 6. Remove 8, remove 8. So what do I have left? Whatever I have left in A gives me the final answer for A minus C. That's 5, 7. So I hope you understand that now. So that's how it works. Correct. Next question is A intersection B union C. First thing is to write out your element for A. The element for A is 4, 5, 6, 7, 8, right? And then element B is what? Okay, let's just go to the straight format. I have B union C. So what's B union C? I've explained what union means. Union means write out all the elements you have for B and write out all the elements you have for B and C, such that the numbers you have or the members is not repeated twice or even more than twice. So now let's list out all the elements for B and C. That's 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Now element for C, 2, 4, 6, 8, 10. Can I write 2? Yes, 2 is not, we don't have 2 before, then we have 4. So if I write 4, that means I have 2 repetition, which is not allowed in this set. So next one, I can write 6. I have 6 already. I have 8 already, but I can write 10. Hence, I already have what? Hence, my B union C is, when I arrange it, I have 2, 3. I have 2, 3, 4, 5, 6, 7, 8, 10. So now the final question says, what is A intersection B union C? Okay, so that will be the intersection I have between this set and this final answer that I have here is what? What is the intersection? 4 is there, 4 is also here, which is an intersection. 5 is there, 6 is there, 7 is there, 8 is there. So suppose this question comes in, computer based test. Suppose you have multiple choice question, and I'm very sure there should be an option. Do you believe that for option A, you might not see 4, you might see 4, 5, 10, 6. Option B, you might see 4, 5, 6, 7, and 10. And option C, you might end up seeing just A. And option D, let's say you have empty set. So you have to be very careful. You got 4, 5, 6, 7, 8. By the time you check for the options and you notice that you also saw, let's say you have 4, 5, 6, 7, and you have what? 10. You might end up saying, maybe it's a mistake. 10, maybe don't write 8, and you go ahead and pick B. Then that means you are totally wrong. So you have to be very careful. This 4, 5, 6, 7, 8, the intersection between the two of them is still equivalent to what? It gives me the element for A back. This is still equals to A, so be very careful of that. So take note of that. So you have just A as a final answer. So I believe that with this explanation I've given you so far, you should be able to solve any questions based on set theory. So for the next one, I think you should also have an idea on Venn diagram too. But at first, these are what you need. The keys that you need is how to find subtraction of a set, complement, intersection, union. You must understand what an empty set is. You must understand what the universal set is. And please take note of this. What of the proper subset? Um, I have 4, 5, 6, 7, 8. Okay, 4, 5, 6, 7, 8. Trivially, I can easily tell you that A is a proper subset of the universal set I have above, because this is a proper subset. I have 4 in the universal set, I have 5, I have 6, I have 7, I have 8. So there exists at least one. So yeah, at least one simply implies I can have more than one element that is not contained in A. I have one here that is not in A. I have 2 that is not in A. I have 3 that is not in A. I have 9 and 10 that is not in A. So it's a proper subset of the universal set. What if can I say A is a proper subset of B? That is, all these members that I have must be inside another one. Yes, I can say A is a proper subset of B. It is allowed. Yes, 4 is there, 5 is there, 6 is there, 7 is there, 8 is there. Okay, so A, the whole, if you notice that the full element you have in A is in another set, then I can easily tell you that A is a member of what? A is a proper subset of the other set, which is B. And there in this case, I can easily tell you that there exists 3 that is not in A. Hence, we say that A is a proper subset of B. But suppose you have just 4, 5, 6, 7, 8. We have 4, 5, 6, 7, 8. Then that is when I will tell you that A is a subset of B. That is, A is a proper subset, and at the same time, it's also equal to, the two sets are equal to each other. That's equality of a set. So that's how it works. That's the main explanation. Sorry, it does not show. So this is what I've been trying to explain this morning. So that's how it works, guys. Thank you.